Okay, like the title says, we're going to be looking at quadratic functions. And the characteristics we're going to be looking at are intercepts, so a y-intercept and an x-intercept, the zeros, what it means, uh, the vertex of a quadratic function, and solving inequalities. So remember, a quadratic function is a polynomial that has degree 2. And degree is the highest power of x in the equation, so any equation with degree 2 is a quadratic function. And you can either write them with an f of x equals or a y equals, because remember with functions we had f of x is the same thing as y. Alright, so I think what's important to mention at the start of this, the functions that I have chosen, it's easy to see the intercepts from the graph. That will not be the case for a function that you get at random. So I've chosen these functions so it's easy to confirm that that's their answer. To look at the y-intercepts, the x-intercepts, to look at the vertex. Those are easy things to do with these graphs. But that's merely because I'm going to show you how to do it with the formula, because you will not be given graphs that are easy that you can get the answer just by looking at the graph. So that's important to understand. So while watching this video, you might think, well, why did I have to do any of that calculation? I could just look at the graph. You will not have functions whose graphs, where you can just look at the graph and get the answer. Okay, so we have 3 functions here, and I've given their graphs. Now, we've got a definition there. The y-intercept of a graph is the point where it intersects the y-axis. And because these are functions, there's only going to be one y-intercept. If we had more than one y-intercept, you would no longer have the graph of a function. So, for example, this graph has more than one y-intercept, more than one point where it's intersected with the y-axis. That is not a function. It fails the vertical line test. So we're going to be looking just at functions. And so as I drew here, these are where our y-intercepts are, and these are all easy to see, which won't always be the case. So the y-intercept of a graph is a point where it intersects the y-axis. For a function, this can only happen at most once. Now, if you have the formula, where do you find the y-intercept? You find it by evaluating the formula at x equals 0. So let's look at this graph here, and this is the formula. So where is the y-intercept? Well, you take the formula and you plug in f of 0. So here's our formula for f, and if I find f of 0, then 8 times 0 is 0, 0 squared is 0, so times negative 2 is 0, and I get 10. So f of 0 is equal to 10, and so the point 0, 10 is our y-intercept. So if we had the formula and not the graph, or the graph wasn't clear at all where the y-intercept is from the graph, this is how you use the formula. So for this function, what is the y-intercept? We evaluate g at 0. And you can see that I'm left with g of 0 is equal to 4. So our function will intersect the y-axis at 4. And so our y-intercept is the point with coordinates 0, 4. Remember, G maps the x-coordinate into the y-coordinate. G evaluated at 0 equals 4 is the same thing as saying the point 0, 4 is on the graph. And if you were to look at the graph, that's confirmed. Okay, if the graph was something easy to see, which is not always the case at all, but we're just confirming that here with the graph. And what about this one? Well, we have our formula. And so H evaluated at 0. So those will go away. H of 0 is equal to 9. And so that's the same thing as saying that point's on the graph, and that's the point that's on the y-intercept, on the y-axis. Okay, now you might have noticed that when you evaluate the function at 0, you're just getting the constant. And so you might think in your head, well, all I ever have to do is to take the last term. Not necessarily. What if you had something like this? What's the y-intercept? Well, you use the procedure that we just went through. Evaluate the function at 0. That gives you -3 times a half, which is -3 halves. And so this function would have a y-intercept of the point 0, -3 halves. Now this, if you were to graph it, it's not at all obvious from the graph what the exact y-intercept is. So this procedure is how you get that. Okay. Now what is the 0 of a polynomial function? Well, a 0 of a polynomial function f of x is any constant, any number c, that will make the function be equal to 0 when we evaluate it at 0. And zeros are also called roots. So if I were to find the zeros of these, I have to set them equal to 0 and solve. And we did this in the last lab. So let's find the 0 of our first function. So the three functions I'm looking at with their graphs, it's the same throughout. So you set it equal to 0 and solve it for x. Fortunately, this factors without too much trouble. So you could always use a quadratic formula here, but I prefer not to if I can factor it. They're all even numbers, so they're all divisible by 2, and the leading term there is a negative number, so just pulled out a -2. And then it's easy to factor that using the trick. And once you have that and set it equal to 0, it's easy to see what your zeros are. So your zeros are -5 and +1. So that one was easy to see because it factored. Now for this one, if we want to find the zeros, we set it equal to 0 and solve it for x. That function does not factor. Doesn't factor with any of the tricks we have. When it doesn't factor, you use the quadratic formula to get the zeros. So your a is 3, your b is -5, and your c is equal to 4. And so using the quadratic formula, we get this. And notice that we have non-trivial complex zeros. These are our zeros. And again, in web work, this is what you would type. You have more than one expression in the top, so the whole expression in the top has to be put inside those square brackets. And then finally, what are the zeros of this? Okay, that factors very easily. If we want to find the zeros, you set it equal to 0 and solve for x and see if you can factor. And there are two numbers that multiply together to give you 9, at the same time add up together to give you 6. And so what solves this? If x is -3, so the zeros are -3. Negative 3 is a repeated 0, so we say -3 is a 0 of multiplicity 2, but there's only one distinct 0, -3. Okay, so let's continue. Now we come to x-intercepts. So an x-intercept is where the graph of the function intersects the x-axis. So you can see this one has two x-intercepts. This one does not have an x-intercept because the graph does not intersect the x-axis. This one only had one x-intercept at -3. Now here's the important point. X-intercepts are found only at the real zeros. So this one here, in example 2, we found the zeros. And the zeros were -5 and 1. And looky here. We have an x-intercept at -5 and an x-intercept at 1. And they're points. So the zeros were real numbers. And we had two real zeros, so we get two real x-intercepts. Here with this second one, we didn't have any real zeros. When we were asked to find the zeros of G, we had numbers with I in it, non-trivial complex numbers as zeros. And G had no real zeros, only complex zeros. And notice that the graph of G has no x-intercept. So that's consistent to saying x-intercepts are only found at the real zeros. This had no real zeros, and so there were no x-intercepts. And then when we did this one for the zeros, we had a repeated 0, but there was just one 0 at -3, and we only had one x-intercept. So just be cognizant of the fact, if you're being asked for an x-intercept or a 0, that's two different concepts. If you have real zeros, they give you x-intercepts. So for this one, if you had been asked what are the zeros and you said none, that would have been a wrong answer. You do have zeros. They're non-trivial complex numbers. But if you'd been asked what are the x-intercepts, the answer to that question would have been none. Okay. Now we're going to use those same three functions, f, g, and h, and let's see what a vertex is. Well, graphs of quadratic functions are parabolas, and they can either open up or they can open down, and they can be thin or fat. But they will either open up or open down. If they open up, the vertex is going to be a minimum. And you can see that's the lowest point. If your parabola opens down, your vertex is going to be a maximum. And we do have a formula we can use to get the coordinates of the vertex. So if you have A, B, and C in your function formula, this is how we plug that in. Okay, so let's see if we can find the vertices for this. And notice, if you use the formula, you don't even have to look at the graph. I only include the graph here so you can see, confirm that the answer is correct. So let's take this problem. And let's look at these. All right, so let's do the first one. So for that, we have A is equal to -2, B is equal to -8, and C is equal to 10. Let's get the x coordinate. So it's going to be the negative of -8 all over 2 times A. Okay, so these two negative signs will cancel. And I'm going to be left with +8 over 2 times -2 is -4. And 8 divided by -4 is -2. So my x coordinate is going to be -2. Now what is the y coordinate? The y coordinate is f of the x coordinate. Right, so that's -2. And so my y coordinate is going to be f of -2. And so that's what we have to find next. So what is f evaluated at -2? Well, I go through the formula here, and everywhere there's an x, I replace it with -2. Now, we have to do that first, or if you put it in your calculator, make sure you have the parentheses. If you don't have parentheses, you're going to get the wrong answer. -2 all squared is +4. And then +4 times -2 is -8. Then we have -8 times -2, which is +16. And then +10. And -8 plus 16 is 8. And 8 plus 10 is 18. So my vertex is -2, comma, f of -2, which is 18. And is it a minimum or a maximum? If you look at the graph, it's going to be a maximum. Now, how did I know that the graph is going to open down? If your leading coefficient, so the number out the front, if that's a negative number, your graph, your parabola is going to open down. If your leading coefficient out the front is a positive number, your graph is going to open up. Okay, so this one will also open up. This one opens down, and so the vertex is going to be a maximum. And now let's go to the PDF and just confirm that. Okay, so I didn't have to graph this. We're just showing the graph to show you that everything confirms. This is how we found our answer. And let's do it for the other two. So now I'm on B. See if we can find what the vertex is. So A is going to be 3, B is going to be -5, and C is going to be 4. And let's see what that's going to be. It's going to be a negative, and then the numerator here is -5 over 2 times 3. So again, these two negative signs are going to cancel, and I'm going to get 5 over 6. So my x coordinate here is 5/6 of my vertex. Now what is the y coordinate? It's going to be f of 5/6. So let's just make sure we're on the right path. So you can see here we found out what negative b over 2a was, and it was 5/6. Okay, so let me get back to this. Now what is the y coordinate? Well, the y coordinate is going to be f evaluated at the x-coordinate. So what is f of, oh sorry, g, my bad, g, because we're working with g now. Okay, so what is g evaluated at 5/6? Everywhere there's an x, you're going to replace it with 5/6 in parentheses. Now, I would probably just use my calculator at this point when you're working with fractions. Clear that. All right, so I'm going to want 3, then in parentheses, 5 divided by 6, close parentheses, and square it. Then minus 5, then parentheses 5/6, close parentheses, then plus 4. Then I'm going to press enter, and I want it as a fraction, not as a decimal. Fractions are exact, decimals are not. So math, enter, enter. Decimals are only exact if they terminate, but this one actually goes on forever. The calculator only takes it to 9 places. But as a fraction, this is equal to 23/12. And that are your coordinates for the vertex. Now, is the vertex a minimum or a maximum? Well, your leading coefficient there is a positive number, so it's going to be a parabola that opens up. And so the vertex, which is these coordinates, is going to be a minimum. And I did all of that without looking at the graph. So let's have a look at the second one. I'm sorry. All right, that confirms everything we did there. And then finally for the last one, let me get back here. What about that one? So let's identify the A, which is going to be 1, B is equal to 6, and C is equal to 9. So let's get the x coordinate of the vertex. So that'll be the negative of 6/18. No, sorry, I just messed up there. It should be 2 times A, and A is 1. I mistakenly wrote C. And so I'm going to have negative 6 over 2 times 1, which is 2, which is negative 3. So my vertex has as its x-coordinate negative 3. And now the y-coordinate is, well, the function is h. And so the y-coordinate is going to be h evaluated at the x-coordinate. And so to get h evaluated at negative 3, everywhere there's an x, you replace it with negative 3. Now, negative 3 all squared is positive 9. This is why you cannot leave out the parentheses or you're going to get the wrong answer. Then I have minus 18 and then plus 9, and that turns out to be 0. So my vertex is the point negative 3, 0. And it just so happens that that is also the x-intercept. It just so happens that's also the x-intercept. So it can be both. And we can also see the vertex is a minimum, but if I didn't have the graph, because the leading coefficient there is a positive 1, we know that it's going to open up, so the vertex will be a minimum. And I think that concludes that part of it. Now, what if you're asked for these things? So we have inequalities. We don't have an equal sign. So instead of where is the function equal to 0, when we're finding the zeros, what if we replace the equal sign with another symbol? What does that mean with respect to the graph? Well, the symbol means everything. If it's strictly greater than 0, then it means where is it above the x-axis. If it's greater than or equal to 0, then where is it on or above the x-axis. If it's strictly less than 0, then where is it below the x-axis? And when it's less than or equal to 0, where is it on or below? And you will give your answer in interval form. Okay. So if we look at example 5, let's look at part A. Find or solve f of x is strictly greater than 0. Or we could be given it in factored form. So we already did this. We already did this before. It was factored. So if you're asking, where are you getting that from? We've already done that when we looked at factoring them to get the zeros. So these two are the same question. Now, sometimes WebWork will give it to you like this. Other times it'll give it to you in factored form. So if we didn't already know what the x-intercepts were, you can see it when it's in factored form. What will make it 0? -5 and 1. So let me do that in black. So -5 and 1. Okay, now the symbol makes all the difference in the world as to what the answer is. If it wants to know what makes this true, the question is, where is the graph above and strictly above the x-axis? Well, in what I'm fixing to draw in red, this part of the graph is above the x-axis. Now, do we include the x-intercepts? Not for this, we don't. Where is it strictly above? So I'm hollowing those out because they're not included. Now, how do we give the answer? You give the answer in interval form with respect to the x-axis. So this stuff in red, how do I use the x-axis to measure that? Well, you go from left to right. I'm going to start at -5, so the answer, that thing is strictly greater than 0, i.e. above the x-axis, when my x values are between -5, and we do not include, see, they're hollowed out, and all the way up to x is 1, and that is not included. That is your answer, and that is an interval. That's not a point. That's an interval. Okay, so that's for that one. What about for this one? So what would be the answer to that one? Or it could be given to us in factored form. Well, because of this symbol, you're being asked, where is the graph on or above. See, equality is included, so on or above the x-axis. And so again, that's at -5 and that's at 1. So on, we will include these points, and above is this part here. And now use the x-axis to measure from left to right for the interval. So we're going to start at, and we're going to include -5. And we have points all the way up until we get to x equals 1, and 1 is included. And so that's what your answer would be. Okay, so again, let's go over and check the PDF. So for part A, there is our answer, which is consistent with what we just did. And for part B, that's going to be for this interval. Okay. All right, let's go back to okay. Now, what about these? So let's look at this one. So where is that going to happen? Or it could be given to us already factored. Well, that symbol is asking you where is the graph below the x-axis. And strictly below. And again, we've got -5 and we've got 1 there. And it's below in this part here, and it's going off that way forever. And it's below the x-axis on that part. And then it's not on, it's just below. Where is it strictly below? So we do not include those endpoints. Now you're going to have to write what's here in red in interval form. Now this keeps going downward and leftward. So how am I going to use the x-axis to measure where that is? Well, there's no leftmost point because it's going to keep going like that forever. So we're coming in from -infinity up to, but not including, -5. And then there's a gap. And we pick it up again at 1, but 1 is not included. And then this portion of the graph will always be below, and it will keep getting wider, so moving lower and to the right forever. And so that's the answer. Where is the graph below the x-axis? That's how you describe what I've drawn there in red. Now on web work, you'll have to use INF. Now look for the instructions, because these are made from different textbooks. Sometimes the instructions will say do INF. Other times the instructions will say to write out the entire word infinity. Sometimes the instructions will say just to use capital I for infinity. Now, if they don't give you any instructions, usually this should be okay. But this is correct, and if it was telling you your answer is wrong, then you might want to go back and type infinity, the complete word. But this should be okay. Otherwise, just use the email instructor button. Now, what if all I do is change this to that? Then the question becomes, where is the graph on and below? And then on and below, I'll still have to pick the part for below, but now I include those because they're on the x-axis. And so the only thing that's going to change are the symbols here, because to measure where this is from left to right, I'm coming in from negative infinity up to and including negative 5. Then there's a gap. I pick it up again at 1 and I include 1. And then measuring, well, this is going to keep going like that forever. We have that. So you'd use a square bracket. So the symbol is very important. If it has equality in there, then you include whatever's on the x-axis. All right, let's go back to the PDF. Okay, so you can see that over here. All right, what about this one? Let me go up here and copy this. Oh, the copy there. And let's make it a little bit smaller. Okay. So what sort of things could we be asked? Well, let's look at g of x. What if we were asked to solve that? What is that asking you? It's asking you, where is the graph above the x-axis? And what happens if you look at this graph? Do you agree that the entire graph is above the x-axis? So where is it above? Well, everywhere. And so if I use the x-axis to measure how wide that is, this is going to keep getting wider and wider forever. So the answer, excuse me, it's above everywhere. What if you were asked for this one? So we're still on this graph. Where is that graph less than or equal to? Well, this is, where is it on or below? And it's not on it anywhere, and it's not below it anywhere. So the answer is nowhere, but how do you type that? You can't type the word nowhere. You'd use the null set symbol or the empty set symbol. So curly brackets with a space in there. And I'd get the same answer if it had just been that. That's asking you, where is it strictly below? Nowhere. Oh, sorry. Empty set. If I had been asked that, what does that mean? That means on or above. Now, it's not on the x-axis anywhere, but it says or above. It's above everywhere. So again, for this one, my answer would be that. Okay. Let's look at this one now. What if we had that? And this is the same thing. What if we had that? Okay. What is this asking us? This is asking us, where is the graph above? Strictly above the x-axis. Well, it's above until we get to here at -3. And at -3, it's on. And this question, they just want to know where it's above. Once we get past there, it's going to be above. So if that's the symbol, the answer is going to be, well, coming in from negative infinity up to but not including negative 3. And then going on to infinity forever. So in web work, you would type that in, unless you're told specifically to type capital I for infinity. Right? Now what about this one? So this is what it would look like factored. Sometimes you get it in factored form. This is asking you, where is it on or above? And now on is allowed because of that symbol. And so it's everywhere now. And there's no gap. If I use the x-axis to measure how wide this is true everywhere. No matter what value x is, it will always be either above or on the x-axis. Now, what if I was asked that? What is it asking me? Where is it below the x-axis? And you can see nowhere is it below the x-axis. And so the answer would be the empty set. So that's what you'd type into web work. But now, again, what if it was given to me in factored form? What would the answer to that be? What is it being asked for, that symbol? Where is the graph on or below? Well, it's not below anywhere, but it is on the x-axis at negative 3. And so the answer to that would just be that. Okay, so that should be enough examples where you have the different types. And now all of your web work questions should cover what we've talked about in this video. So I'm going to stop the video there.